Hello and welcome to the Security Week podcast. My name is Mike Lennon. I'll be your host today on behalf of the Security Week team. Thank you for joining us. This week we are focused on a segment on industrial security. I'm here with our guest today, Andrew McPhee. He is Solutions Manager for Industrial IoT over at Cisco. Andrew, really excited about this. As you may know, this is a topic that is near and dear to me as director of Security Week's ICS Cybersecurity Conference. So I love diving into these types of topics and kind of hearing some of the things that you're seeing on the street and what you're dealing with out in the field with customers. So the kind of theme here is embedded IoT security, kind of the network native advantage. So before we kind of get deeper into the technical aspects of that, can you kind of start with the big picture? OT networks have fundamentally changed over the years. At the conference over the past several years, we hear a ton about the convergence of IT and OT. Sometimes I feel that the topic's overdone, but then every year it is still just a hot topic. So I think it's definitely not overdone yet. So can you kind of walk us through, what's driving this convergence between OT and IT, and kind of what are some of those risks that have emerged, as a result of this conversion?
Yeah, for sure. And first of all, thanks for having me. So I'm excited to be here as well and get to talk about this. But yeah, IT/OT convergence is actually something that we've changed in Cisco calling it IT/OT partnership, because the word convergence almost means it's going to be one, and it's going to be either IT or OT. But it's more the partnership that has to develop in order to allow the connectivity to happen that is required for these modern automation systems. What's really changed over the years is just the need for more and more connectivity. There's more and more benefits to connect that OT data to a service that's going to give you things like predictive maintenance, or how can you reduce waste so you can save costs on your production. The vision systems that we see now in production line doing quality control require so much bandwidth and so much compute to be able to process at the speeds in which they can process. And with every new kind of technology that gets introduced, well, that means more and more connectivity is needed, and with more connectivity becomes more risk exposure. There's a customer I've worked with. I always like giving this example because it's a chocolate factory, and people get excited when I say the word chocolate factory, but it's a food manufacturer that makes chocolate. Yeah, and they have a mixer. And within this mixer, when they're mixing the chocolate, every so often it starts to harden. And the way that they know that there's going to be a failure is the vibration sensing of the mixing bowl. Whenever the vibration patterns change, they know that there's going to be a failure coming soon. Whereas before, they had to wait for the entire process to fail, and it could have been a few days of downtime just to get the machine cleaned up and scraped out. So, yeah, getting access to that data is imperative for business continuity, needing networks, but then that opens up security risks.
Yeah, absolutely. Okay, that can kind of is that also kind of fall into something that could be used for like predictive maintenance too. If they sense something, and again, I don't know much about this factor, but I'm thinking if they detect that vibration, is it something that can be addressed, not even necessarily from a security aspect, but just from an operational resilience aspect? Say, okay, this thing's about to fail.
Exactly.
We know what happens next. Not necessarily. That's cool.
Predictive maintenance is it's a huge it's a huge use case. And that's the thing about security. I know we're going to talk about security today, but the reason we need security is because we needed connectivity. We don't want to just put in security products just because we now want to be secure. You don't need car insurance if you don't drive a car. It's right. The reason you get security is because you needed the connectivity in the first place, but you want to make sure you're doing the connectivity in a secure way.
Yeah, that's a nice added benefit too, right? Have security on top of your predictive maintenance. Okay, so that being said, kind of shifting more on to the visibility issue. Again, another very popular topic that's been addressed at our conference and many other conferences and webinars. Asset visibility, what's happening inside your environment, across your network, on your devices. So many organizations have scrambled, I know, over the last few years to adopt many of these tools that companies like you and some of your competitors are doing. They're adding monitoring appliances, span ports, and other tools for visibility. So what are you guys seeing? Are they actually getting value from this? Is it more just a bolt-on approach? What's the benefit here?
Yeah, so there's always debates within the security world of where do you start in your security journey, and for most people, when they bring their product into the conversation, they're probably right with the problem that they're trying to solve. There's so much to do in security that no matter what we try and sell you, it's probably going to help secure your network. But there's a reason why we say, visibility is the first thing that you do, and it's to really understand what is the risk that you're exposed to. So, I mentioned earlier on about, you don't need car insurance if you don't drive a car. Well, what is it about your OT that you're trying to secure? Like, do you need remote access into the OT network? If so, you need to do it securely. Do you need to collect data from that mixing bowl to do predictive maintenance? And if so, how do you make sure an attacker can't also access that mixing bowl and put it to a halt? So visibility is that first step, just to give you an understanding of what actually your network looks like. Like, what are those exposure points going to be? What is currently connected? What is exposed? And what are they doing today in order to then inform a protection plan later on? And you mentioned the span ports and the kind of the bolt-on solutions. How we get visibility in OT isn't really rocket science. We do deep packet inspection of OT protocols. So if you give us access to your data, we'll tell you what's happening and give you insights into that data. But getting access to the data is a part that can't really be overlooked. What tends to happen is, in order to get access to this data, in order to do deep packet inspection, I need to take a copy of all of the data that runs through your network, almost like a digital twin, if you want to use that terminology. And in order to get that, we typically put span ports in the network. We'll go to your existing switch infrastructure, tap it, and say, give me a copy of that data, and I'll give you analytics. It requires more hardware, more cabling, more power, just more kind of operational overhead in an industry that we're trying to reduce hardware. You see things like virtual PLCs and the digitization of plant floors. They're trying to go towards more software. So as security practitioners, we can't just try to introduce more hardware. This Cisco approach to it, while we're doing deep packet inspection like everyone else, we're also a networking company. We're also, have been doing industrial Ethernet switches and ruggedized switches for over 20 years now. So we just embed visibility within the switches. The same switches that you're using to get connectivity in the first place are the same switches that will give you the visibility on what's going on and what are the vulnerabilities that those devices have. So later on, when you're ready to put in a protection plan, you have all the information you need to do so.
Okay. And part of that, I know a topic that I see and know a little bit about is, you're differentiating between, in some environments, industrial and enterprise traffic. Can you kind of dive into or explain to people that are not familiar with the kind of difference between the east-west versus north-south traffic flows, particularly inside, an OT environment, and how that kind of differentiates from typical traffic?
Yeah, for sure. One of the ways that we've represented the OT networks, or the convergence of IT and OT networks, for many years now, is with that Purdue model. So most listeners probably know what that is, where the enterprise network is that layer 4 or 5, the OT network is 1 to 3, or 0 to 3, and then you put that DMZ in the middle. Typically, when we talk about north-south traffic, we're on about traffic that leaves the process zones and works its way up that stack. And that's what north-south. It's between, say, the DMZ and the OT, or maybe there's an industrial data center in the OT. It's your traditional IT stack, your IT deployment, your servers. We would have called it a server room back in the day. Some of them now call them mini industrial data centers because of how big that they're getting. But that's typically your north-south. And those protocols that are used, that communication is used, is your typical IT protocols. It doesn't really differ much from what you'd see in a traditional enterprise network. It's kind of server-to-device relationships, or known protocols. Within the OT itself, though, the things that actually does the process control, that's what we mean by east-west. It's everything that sits within those cellular zone boundaries. It's the communication that goes up and down your production lines to make all of the magic happen. It's the Rockwell communication that uses, Ethernet IP. It's the Siemens communication that's doing Profinet and S7 and Modbus. And it's those type of flows in the network. And from an OT visibility perspective, that's really the kind of the goal. That's the stuff you're looking for, to really understand what these OT devices are doing, be able to profile them correctly, be able to get the correct posture. And then, that's where we go to that embedded visibility again. It's if you're not seeing that east-west traffic, you're not deep enough in the network, it's quite hard to really gain getting a full picture of what's going on.
Sure, exactly. Which is, you kind of mentioned seeing that traffic. I know traffic visibility, network visibility it's not new. There have been tools for network monitoring for decades. What makes it different, and where are the gaps inside industrial networks that maybe some of these older legacy traditional network monitoring tools are missing? What's happening there?
Yeah, it's mainly just the makeup of the protocols themselves. So when we think of IT visibility, we typically think of things like NetFlow, where we analyze the IP addresses or MAC addresses, the ports that are open. Like, oh, we see that this port 22 is open. We see that port 54 is open, 80, 44, 443. Like, we just look at that level of detail. Whereas in an OT world, while they use Ethernet, while they use TCP and UDP as the kind of transport mechanism, the data, the interesting data is within the payload. That they've taken those serial protocols that would have existed in legacy OT networks and they've run them over Ethernet. So OT visibility tools have to be able to parse that traffic in a way that they can actually understand what's going on. It doesn't help you too much to know that these ports are open between two devices, but when you look deep inside to find out what's happening, that's when you can start to see the real communications. I'll give an example of Schneider Electric PLC has a vulnerability. You can patch it now, but it's within the Modbus stack. If you were to write to a certain memory location with a particular set of values, it would return the password of that PLC, and then you could use that then to authenticate to the device. You only know that because you can do payload inspection within these visibility tools. So it's important that you actually can really understand what's happening at a protocol level, not just at a traditional IP stack.
Okay. Very interesting. Obviously these tools cost money. Some companies, some of the larger manufacturers, governments, the budgets might not be as much, always an issue, but maybe not as much of an issue. So beyond kind of the technical limitations, there's an economic dimension here that we, maybe should talk about. So when somebody's trying to implement these tools, what are some of the hidden costs that some of these organizations face when they're trying to scale these, across their network? And a lot of them are not just one facility. They might have multiple facilities, across the country, even small to mid-sized manufacturing companies, multiple locations. How do these scale and how do you kind of manage them with infrastructure costs?
Yeah, there's a good example of a utility that we worked with in Brazil, CPF. We have a case study on it if anyone wants to go and check it out. But I think they have almost 700 substations in Brazil. So quite a large footprint of remote sites that they got. And they were evaluating multiple different solutions. And inside of a lab, it's quite easy to evaluate these things. You're normally pitting capabilities against each other and say, can this vendor do X? Can this vendor do Y? But when they came to do the real world implementation, that's when a lot of the struggles of how they're going to operationalize this came about. So when you talk about kind of the scale and the hidden costs, well, if you have 700 substations and you need an additional piece of hardware in every single one of those substations, that's 700 boxes that you have to buy. If you're not doing deep packet inspection in an optimal way, and you still require a lot of traffic to be sent from your sensor all the way back into the hub location, and you're paying for your bandwidth, like it's cellular, maybe it's low bandwidth satellite, you're paying for that transport cost just to get the data out of those substations. Again, if you have additional hardware, you have additional cabling. In a substation, that's not so bad. It's quite a short hop, but in a manufacturing plant where your ceiling's maybe 30 foot high and you need to get it sewn out with a scissor lift to get up into that, to run the cable down and get all that data back. It's just quite a lot of operational overhead. So, we harp about it all the time in Cisco, but that Brazilian utility, because they were using our routers anyway for the communication, and they were due a switch refresh, it made sense to combine those efforts as they were modernizing the infrastructure. They saw that they could embed the visibility in. Our DPI happens locally, so we only send metadata back. It's about 2% of your traffic, maybe 5% at the most. So even on those satellite-based sites, we're able to run DPI and get the data back. And it's just it's those that are kind of hidden costs that come with it. It's much different doing an evaluation in a lab than it is doing it in the real world. And we have found the embedded approach is the way to scale.
Yeah, absolutely. My next question kind of goes back when I introduced the podcast today. I mentioned network native security and kind of talking about the network native advantage that I know Cisco talks about. Can you kind of dive in? What is network native? What does it mean? So you've talked about overlays and bolt-on approaches. What is network native or embedded security, like in the context that you guys see it?
Yeah, I think at one point in time, and we still see it a bit today, but it's getting better. Networking and security would have been considered two separate pillars, like completely separate pillars, that you had a team that handled the networking, and then eventually your traffic hit a firewall, and that's when the security team took over. They managed, they just had different responsibilities, and they still do today. The security team has different responsibilities than the networking team. But as technology has improved, and so has the kind of the native capabilities, those network devices, to also become your security appliance. We do see customers that can have architected a network in a way that they say, like, reroute all of their traffic through a firewall to get from, say, zone A to zone B. And I'm not saying that doesn't work. It does for some. But I have other customers who thought that they were doing that. They thought that they had a firewall that was protecting their production lines, and they'd done a cybersecurity audit because they needed it to get cyber insurance. They thought they would pass. Turns out during that audit, the OT was just bypassing the firewall by just daisy chaining all of the switches together. And the security team was essentially out of the loop. No visibility, no control, essentially no security across the plant. Unless you're doing security down at the point of the network, it's kind of, you're always fighting a battle of bypassing those bolt-on security solutions. Someone's always going to cable around it or find a way to bypass security. Hopefully no one from Cisco IT is listening, but we do it as well in Cisco. There's certain lab restrictions we have, and some of us are smart enough to get around some of the things that even Cisco put on us. So we always find ways to get around the security constraints under us. So yeah, the built-in security is really just, it's always saying that the network devices that you're investing in are also your security appliances. So we talked about visibility, but they also do segmentation. They also do access control. We also can block two devices on the same switch from completely seeing each other. So it's there's much more capability on these switches than maybe there once was in the past. And it's not only the convergence of IT and OT, but security and networking working together on the same set of hardware.
Okay, cool. So that deep packet inspection that you mentioned, that is something you mentioned can be done within the switches and routers?
Yeah. Within the Cisco Industrial Ethernet switch, there's deep packet inspection for OT visibility. There's segmentation of the OT network. There's zero trust network access for remote access. So, dedicated tool for that within Cisco as well. All of the security that we really bring into this OT space, you can host it all on these switches and these routers. Yeah.
Okay, and can we dive into a little bit of the technical architecture? We talked about it a little bit, but kind of reverting back to the north south and east west traffic. What makes everything architecturally different? When you do implement a switch or router that kind of has these capabilities, is it just massive simplification?
Yeah, there's a lot of, one of the sticky points in OT when it comes to moving from visibility into control. I think that's another sticking point that our customers have is they all want to do segmentation. They all want to take control of the OT network, but it's hard to find a starting point. And I've spoken to customers who every production line is in its own network segment, and they'll use a firewall to route between them. And that's great if they've done it. I would never tell them to stop doing it, but normally the intention is to go a little bit further than that. What if I want to now separate a production line into its different cell area zones, or if I have a customer calls them segments, every segment has multiple stations. What if I want to do a segment at the station level? Do I now need to invest in a firewall for every station instead of a firewall for just doing kind of my routing point? And we don't want to do that. We don't want to put firewalls everywhere. Firewalls are great, but managing 300 firewalls is not something anyone really wants to sign up for. And any of other customers we see all the time where they have a flat network, or relatively flat network, where their entire OT install is kind of on a /16 or even a /8, and they're not able to force traffic through the point of a router. So within the switch itself, we can do segmentation without changing any of the networking constructs. You can have 4 production lines all running on the same subnet, but each production line could be assigned to a unique security group that keeps them isolated. A customer I met with yesterday, they call them work areas. So they wanted to isolate 2 different work areas that were sharing the same physical infrastructure. And it's not a problem at all. We'll just put them on 2 logically isolated zones without changing their IP address. And those 2 things are restricted from communicating to each other. So that's one of the key advantages of doing it at a switch level, is the flexibility that you're given.
Okay. I assume a lot of this helps with compliance as well, and then ISA and IEC 62443. Not everyone
exactly.
But it's again a nice side benefit of having a lot of these things implemented and making it easier to be compliant.
Exactly, yeah. That the zones and conduits model that's laid out by 62443 is also something that's been picked up by NIST in Europe as well. They're using the same language. NIST, they have their zero trust guidance based on microsegmentation. They'll tell you to do the same thing as it's groups of resources on a unique segment, and then policies between them. They call it out. They say between switches, routers, or firewalls. It's recognized now within these compliance and these industry guidelines that switches are an adequate choice for the segmentation of an OT network.
Okay. Next up is the topic of disruption. One of the biggest fears that we see in OT security and OT in general is downtime. Whether it's a factory, whether it's a turbine, a power plant, that's obviously a big one. Patching and doing all these things that a lot of the people on the IT side don't think much about. And OT is a big thing. You also mentioned firewalls earlier, that one of your customers had an environment where the team was circumventing the firewall very easily. It basically wasn't doing its job, mainly, I'm assuming, because it wasn't configured correctly. So one of the biggest fears in OT security is kind of inadvertently disrupting production. So how do these practitioners, when they're implementing a lot of these tools, technologies, and architectures, how do you kind of ensure that we don't cause downtime? Again, not malicious, just mainly from during the configuration and deployment process.
Yeah, there's 2 key points. One of them is there's a term, I don't know who came up with it. It was probably Gartner, called virtual segmentation, is where you use your visibility tool to almost mimic your segmentation environment. That zones and conduits model that I mentioned. We'll use our product Cisco CyberVision to display your data in the zones and conduits way. So before you've ever put policies on a network, you can see all of the security zones that you wish to build, and you can observe what the communications are between those zones. So when you're ready to build policies, where you have a full kind of observation of all of the things that exist today and have existed over the previous months. So when you build policies, you're not going to make any mistakes within that. And as Cisco are using things like switches for segmentation, using identity services engine. If folks on the call are familiar with that term, there's ways to deploy it in a non-intrusive way that you're not going to drop the traffic. You log potential drops, but you won't drop it. So we have technology techniques there, but the main design technique is just starting off with a virtual look at the world and then pushing it into the physical world later on when you're comfortable. But the second thing is cybersecurity is about managing risk, and that visibility was part of that risk assessment. I want to assess the risk that they have. But then at some point, customers have to have a level of risk acceptance. we all say we want to do microsegmentation, but for most true microsegmentation, port level microsegmentation, where you trust absolutely nothing, is very operationally expensive. So you start to accept some risk. And if you've never done segmentation before, I'll take an automotive customer as an example, and you have a body shop, a paint shop, and an assembly shop. Your first protocol might just be, I'm going to accept the risk that anything within the paint shop can communicate with anything in the paint shop. But I'm going to make sure that if something was compromised in the paint shop, my body shop is unaffected and my assembly shop is unaffected. And that's your starting point. That's your first level of risk acceptance. And then when you've finished that project, you might look at that paint shop and say, well, I want to segment my paint shop. I'll get the body, I'll get the assembly later on. But the paint shop, I'm going to focus on paint shop. And you just take that iterative approach to security and to segmentation. Eventually you'll get there. If you try and start microsegmentation day one and decide I'm going to take on this huge project, it won't go anywhere. You won't be able to get started. So it's iterative.
Yeah, absolutely. So as we, in your position, as we, kind of wrap up our chat here today, in your role, I'm assuming you talk to a lot of practitioners, you talk to a lot of customers. For listeners out there and people who are maybe starting their journey or midway through their journey, and even people that are well into their journey, what's the one thing that you would like these practitioners to take away from our conversation today, and that they can kind of take back to their team or discuss internally?
Put together what that protection plan is going to look like. Not now, not in 6 months, but in about 3 to 5 years time, what would good look like for you, and then work backwards from there. So we want visibility to drive protection, whether that's protection from that zones and conduits, that segmentation of the network, whether that's remote access, and that you have a legacy solution that you need to upgrade, whatever it is. Get an understanding of what those risk points are, and then define a long-term plan of how you're going to fix it and work backwards from there. Make security an iterative process where you take baby steps towards the larger goal. Don't try to take the larger goal all in one shot. We recommend to start with visibility to get the lay of the land, and then go on a segmentation journey. But there's always customers who are in a different level of maturity. If you already feel like you're mature, that's great. But what's next? How are you going to protect it from that?
Yeah. There's always more you can do. That roadmap never really ends.
Yeah.
Andrew, thank you very much for coming on the podcast today. Enjoyed this discussion. Wish we could have some more time. I could go for hours on this stuff, but thank you so much, and we hope you have a great day.
Thank you for having me.